Hello students, in this video I am going to discuss types of mixture in chemistry. In my previous video I have already explained that substance can be classified into two types, pure substance and mixture. Pure substance again can be classified into two types, elements and compounds. Mixtures are classified into two types, homogeneous and heterogeneous mixture. Homogeneous mixture is called solution. Heterogeneous mixture again can be classified into two types, colloid and suspension. In this video, I am going to discuss about the homogeneous mixture. Now, if you look at this picture, you can clearly find out that which type of mixture is called heterogeneous and which type of mixture is called homogeneous. Now, in this picture, you can see it may be a salt solution or sugar solution. That means we have added salt or sugar into water, but we cannot find out salt or sugar from this mixture. So that's why it's called the homogeneous mixture. Now in this picture you can see that you can find out all the components. These two components are visible. That's why it's called heterogeneous mixture. So there are lots of examples are there from our everyday life which is actually homogeneous mixture, like salt solution, sugar solution, lemon juice, orange juice. These are all examples of homogeneous mixture. But remember, orange juice should be without pulp. If pulp will be there, then it will be heterogeneous mixture. So according to chemistry point of view, the definition of homogeneous mixture is that homogeneous mixtures are mixture of two or more compounds or elements that are not visually distinguishable from each other. So if you look at all these three pictures, you can't find out the components separately. It's everything look like a same thing. So that's why it's called homogeneous. Homogeneous mixture is called solution. Solutions can be classified into two parts, solvent and solute. Solute means which we take less quantity, solvent means which we take in more quantity. Like when we make salt solution, we take less amount of salt and add into more amount of water. That's why water is called solvent and salt is called solute. Similarly, in the orange juice, the quantity is more, so that will be solvent. And sugar, if we add sugar in the orange juice, then sugar will be solute. Similar like homogeneous mixture, there are lots of examples are there in real world which is actually heterogeneous mixture, like from pizza to fruit salad to cookies. These are all heterogeneous mixture because here all the components are visible. So chemistry point of view, the definition of heterogeneous mixture is that these mixtures of two or more compounds are visually distinguishable from one another. Now homogeneous mixture can be different types. So brass is one of the example of homogeneous mixture which contains two different types of solids. So brass is a mixture of 65% of copper and 35% of zinc. So here copper and zinc atoms are not chemically bonded. So this is the points I have already explained in my previous video, that what is the main difference between a pure substance and mixture. Mixtures contain more than one elements or compounds, but they are not chemically bonded. That is called the mixture. So in copper and zinc atoms, they are not chemically bonded in the brass. So that's why brass is a homogeneous mixture. And here both the solid and solvent are solid. So this is a example of solid-solid solution. And it is a homogeneous mixture because copper and zinc are distributed uniformly. You cannot make out that which is copper atom, which is zinc atoms. Cold drink is also an example of homogeneous mixture. Cold drink is a mixture which is made up of carbon dioxide, sugar and water molecules. So when it is an unopened cold drinks, you can't find out which is gas, which is sugar or which is water molecules. These are uniformly distributed. That's why it's a homogeneous mixture. And here sugar and gas quantity is less, so that's why sugar and gas is solutes and solvent is water. Here is an example of homogeneous mixture. Here is a mixture which is made up of various gases like oxygen, hydrogen, nitrogen, carbon dioxide, sulfur dioxide, and all these gas molecules are not chemically bonded. So that's why here is called a homogeneous mixture. And here both solute and solvent are gas. So it's a gas-gas solution. And it is also a homogeneous mixture because you can't make out oxygen, hydrogen, carbon dioxide molecule from the air. So that's why air is called a homogeneous mixture. So since we cannot find the components which present in the homogeneous mixture, then how to separate them from the homogeneous mixture? So homogeneous mixture can be separated into their component substance based on two different physical properties of the components. One is the boiling points and second point is the solubility. So when the two components which is present in a mixture and they have a boiling point difference, usually it should be 20 degrees Celsius difference, then we can use a technique which is called fractional distillation to separate the components from the homogeneous mixture. And if the solubility difference is there, then also we can separate the mixture using a technique which is called crystallization process. This is a technique which is called fractional distillation technique, which we use to separate the components from homogeneous mixture of two liquids which are miscible or maybe one solid which is dissolved in liquid. In this picture, you can see this is called a round bottom flask where we have taken a salt water. This is distillation apparatus which is connected with water. So this is water inlet and this is water outlet. It makes the outer layer of the distillation apparatus cool, and this is connected with another round bottom flask where we are going to collect the components from the homogeneous mixture. So here we have taken salt water. Using the Bunsen burner, we are heating it, and when it will reach to 100 degrees Celsius, this is the thermometer. Here you can see it measures the boiling point temperature, means what is the boiling point of the solvent. So when it reaches to the boiling point, water will start to boil and it will be in the gaseous form. So it will reach to the upper portion of the round bottom flask, but now distillation apparatus is cold due to water flow. So as soon as it will reach to the distillation apparatus, water vapor will start to condense and it will move this way and collect in the receiving round bottom flask. This is the way we can distill out all the water from this salt water, and here only salt will be remaining. Same way we also can separate two miscible liquids. Suppose we have taken two liquids A and B. A has the lower boiling point than B. So when we start to heat this round bottom flask, A will first boil and it will collect to the receiving flask, and B will be remaining here. So this is a very popular technique, fractional distillation, which is commonly used in the chemistry lab to separate the homogeneous mixture. This is another technique which is called separating funnel technique, which is used to separate the compounds from homogeneous mixture of two liquids which are immiscible. Miscible liquids can be separated by fractional distillation, but immiscible liquids can be separated using separating funnel technique. This simple glassware is called separating funnel, and when we add two immiscible liquids in the separating funnel, they form two layers. The liquid which has higher density, it will be in the bottom layer, and the liquid which is in the lower density, it will be in the top layer. As an example, if we mix oil and the water will be bottom layer and oil will be the top layer. Then we can collect the two layers separately and we can separate the two liquids from the homogeneous mixture. Now crystallization is one of the technique which we use to separate the components from the homogeneous mixture. So usually this technique we use when solid is dissolved in liquid. So here we have taken one organic compound which is called anilide and which is dissolved in water. And now you can't make out, it's a homogeneous solution, so you can't make out where is the anilide. So you want to separate the anilide from the mixture. So if we keep it for, if we cool it down and keep it room temperature for few hours, we can see slowly that crystal is forming. The white color crystal is forming. These white color crystals are nothing but the acetanilide. So this is the way we can separate homogeneous mixture using a technique which is called crystallization technique. I hope the concept of homogeneous mixture and how to separate the components from the homogeneous mixture is clear to the students. If you have any doubts, you can send me a mail to chemistry.affinity@gmail.com. And if you like this video and if you think this video will be helpful for your study and it will enhance your concept, then share it with your friends and subscribe my channel Chemistry Affinity. Stay tuned to know more such fundamental concept on chemistry. Next video, I will discuss details about the heterogeneous mixture and how to separate the components from the heterogeneous mixture. Thank you for watching it.